members of Community Conversation Series. On the behalf of University Housing, we'd like to welcome you to this program called It's Elementary, My Dear Watson, the Philosophy and Science of Artificial Intelligence and the Turing Test Simulation. Just so you know, the Community Conversation Series is an academic initiative produced by the University of Housing and also with the help of the Oregon Brain Tank, which is an undergraduate academic group in the resident halls. So if you're interested in helping out with that, we meet every Tuesday at 5:30 across the way in the LLC conference room, and that's a great opportunity to make kind of these programs and build your ideas up. So we encourage you to join us for that. And we'd also like to acknowledge some of our co-sponsors, the Robert D. Clark Honors College, the Oregon Humanities Center, and Undergraduate Studies, and of course the U of O libraries, which have made this possible for the past 8 years.
At this time, it is our honor to introduce our esteemed panel and moderator. In the back, we have Jim Allen, who helped to organize and moderate the event. Our first panelist is Ken Valente, who is visiting us via Skype. He will present first, and he's on East Coast Standard Time. And at the end of his presentation, we will open it up for questions for Ken, because it's so much later in New York. So if you have questions, we'll come around with the mic so he can hear the questions. Ken holds a joint appointment as Professor of Mathematics and Interdisciplinary Studies at Colgate University, where he's also the Director of Lesbian, Gay, Bisexual, Transgender, and Queer Studies. As for the rest of our panel, we have Dejing Dao, where are you? In the back, whose research is in automatic virus detection on the internet using automated data mining, Web 2.0 enhancements using information integration models, using natural language through semantic relationships, and his main hobby is soccer. We have Daniel Loud, whose research is in automated machine learning techniques, and his main hobby is choir. And finally, we have Stephen F. Fickus, whose research is in software requirements, which is formal ways to get people to say exactly what they want their computer to do, accessibility software for individuals with traumatic brain injury and developmental disabilities, wearable and ubiquitous computing. His main hobby is surfing. Please join me in welcoming our panelists.
So I take it it's my cue. Right, well, thank you for the invitation to participate this evening. It's wonderful to be connected to Oregon, and if it is remotely. I'm having a bit of a feedback problem here, but I'll just continue to speak if you nod that you understand. Fair enough. I've been asked to give about a 10-minute overview of Alan Turing's contributions to artificial intelligence. 10 minutes. 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 10 min
success. So how many of you have used artificial intelligence today? At least one, two, three, four. Can you give an example of the artificial intelligence you used today? Smartphone? What's that? Smartphone applications? Any others? Google, good. Any other interesting applications of artificial intelligence that people use today? Yes. Wolfram Alpha, yes. Lots of interesting things going on in there. Any other artificial intelligence examples? Anyone use a calculator today? Does that count as artificial intelligence? Maybe. So the question of what intelligence is kind of a sticky one. Because there are things that are easy for humans and hard for humans and easy for animals and hard for animals and easy for computers and hard for computers. And so precisely what we mean by intelligence is a question that is perhaps better left for philosophers. So I won't get into that too much, not being a philosopher. But I just wanted to get you all thinking about artificial intelligence and how it's already impacting your lives and all the ways it will continue to impact your lives even more and more in the future. People once thought that the artificial intelligence question would be solved pretty quickly. And it's taken longer, but we've seen a lot of cool things in that time. So
maybe I ask one more question. Which movie you think is mostly about AI? Yeah.
Blade Runner?
Huh?
Blade Runner?
Blade Runner?
Blade Runner.
Blade Runner, I see. So AI, yeah, that's a movie called AI. So what's else? Tron. Okay. The Matrix, yeah. Okay, I will talk about it later. Good. Okay, so Danny, go.
We'll know that we've succeeded in building intelligent computers when they all destroy us. And then we'll have achieved something. OK. So we're going to start by talking about some of the ways in which computers can already imitate humans and perform at a human level in many different ways. You already know about calculators. Computers are certainly better than humans at arithmetic. But let's look at some of the other examples, and then we'll get into an example of a Turing test. And you can see how well current chatbots compare with current humans in their ability to act like humans. OK. So we just talked a bit about what intelligence is. And it's tricky to define. And if only we had a philosopher here, then we could be even more confused. So some possible definitions are that intelligence separates humans from other organisms. Some people would like to define intelligence as sort of that which makes people better. And as computers get better and better at things like solving your math homework or translating between languages or driving cars, humans perhaps get more and more threatened because the computer seems to look like a smarter and smarter organism. Or perhaps it's the ability to act in a way that results in optimal outcomes. If that's true, then I'm probably not intelligent, because I certainly don't achieve optimal outcomes consistently. Or perhaps the best definition of intelligence is it's just sort of like you know it when you see it. If something is intelligent, then you look at it and you think, yeah, that's intelligent. Anyone have any other definitions of intelligence? Yes. Yay. Yeah. Represent.
This might not be an answer in one of the questions, right? But where does sentience fit in?
Good question. So, yes, self-awareness. How do you test for self-awareness?
There's some debate if you're self-aware or not. We all kind of think we are, but there's debate about that.
It might just be an illusion.
It might be.
And then if you have animals like dogs and cats may not be able to pass the Turing test, but they have some kind of intelligence, right? Even if it's not the ability to solve your math homework or drive a car or pass the Turing test. So other comments before we continue?
The one that often comes up for this is learning. No one mentioned that, but the ability to learn is often
The ability to build culture.
and destroy it, right?
So how do you define culture? That's a very
Yeah.
interesting definition. How do you define culture? That's why I'm asking you. Yes. Cool. So maybe intelligence is a social phenomenon that emerges when you have a group of intelligent creatures that interact with each other, and isolated creatures are never going to look very intelligent because of whatever reason. They wouldn't have much need for their own culture of one. Other people want to jump into the fray. Have your say. Okay, a few more examples then. So let's look at some cases where humans may or may not be competitive with machines, or machines may or may not be competitive with humans. So which do you think would be better at predicting probabilities in games of chance, humans or computers? My guess is that actually for a lot of them they'd be the same, it's just humans are slower. But given enough time, they'll probably come up with the right answer in most cases. But computers would certainly be faster. How about remembering how to get out of a maze? Humans? Depends on the computer. May also, what's that? Depends on how the maze is defined. If the maze changes. Like if I take my laptop and I drop it in the middle of like a corn maze, it'll probably be stuck there for a long time. So it depends on how you define a lot of things, right? But computers are certainly able to remember a lot of things. So if it was just down to remembering a lot of stuff, a computer is good. So is a book, for that matter. I don't know if you consider a book intelligent or not. It can certainly learn if you keep writing in it. I don't know. Win at games. Who's better at humans or computers? Depends on the game. And depends on the human and the game. What are some games that humans are better at? Physical games? Yeah. Yeah.
How about social games? Probably poker I'd consider somewhat of a social game.
There's been a lot of progress recently on poker.
No, I know.
Yeah.
Yeah.
But humans still have the edge, except for, is it 2-card limit Texas Hold'em is the only one where I think computers are competitive yet. So one of the simplest possible games of poker, computers are competitive at it. But long way to go in others. Long way to go and go. How about designing a scientific experiment? Humans? Generate a realistic-looking fake stock history. I don't know where that one came from. Or painting a religious fresco. Probably humans. I would tend to agree. Hold a conversation. Maybe depends on the human. Okay. Okay. So let's look at some examples of a few of these before we actually try out the hold the conversation one. Okay, so we agree on at least predicting probabilities. So someone brought up the idea of soccer. So humans certainly are still better at soccer, but people are trying to change that. And they're starting with RoboCup. So the initial RoboCup games were mainly played. Have you seen those little Iber robots? They look like little dogs. Taking those little robots and trying to program them to chase balls and pass it to each other and score goals. And it is sort of cute. You try to give them every advantage, so an overhead camera and a brightly colored ball, so everything's easy to find. And they're trying to slowly up the difficulty as they develop better and better methods for actually coordinating these robots, having them work together with each other to successfully play this game automatically. And the goal is to eventually get it to where you have real human-like robots actually playing soccer.
Yeah, I can talk about it more. Yeah.
Okay, go ahead.
Yeah. So the picture shows here is called humanoid robot. So you can see robot looks like a human at his shape. So Daniel talked about another group that's usually called Sony dog. So the like a dog that's made by Sony company, but they didn't make any more. And I was in RoboCup 2000 in Melbourne, Australia, when I was a graduate student. So we are in a group called small size group, basically just 5 small vehicles. And for the small vehicles, they don't have intelligence in each robot. They have a central camera to watch the whole field, and they have one computer to control 5 robots. For this humanoid robot, actually, each robot has a computer suppose inside. Okay. So the goal for RoboCup actually is in 2050, hope that RoboCup champion can play with World Cup champion, with human.
Play better than the U.S.
Definitely.
It will be the U.S.
So if U.S. cannot get a good team, we have a robot team to play with like Argentina or Spain, right? Okay, so that's RoboCup, yeah.
Okay. So with other games such as chess, how many people have heard of the Deep Blue chess thing? Maybe half, or maybe the majority of you who are willing to raise hands. I'm never sure how to interpret these probabilities when I ask for hands raised, but at least some. I have a lower bound. And then how many of you have heard of Watson? Yay. So more. So these are both IBM projects. IBM has a lot of money, and sometimes they put some of it towards really cool things. So towards building a really effective chess-playing computer, and more recently towards beating the human champions at Jeopardy. And this is sort of exciting and inspiring because Jeopardy has a bunch of these challenging trick questions and a lot of natural language processing, a lot of recalling, and the fact that a computer is able to do that so well is, I think, encouraging, especially when you think of the applications they're looking towards in the future, such as medical diagnosis. So you may or may not care about having a Jeopardy-playing robot in every home to sit on the couch next to you and say, I know the answer to that. But in terms of things like medical diagnosis, the application becomes a little bit clearer. That's just a really cool demonstration of what you can do with today's technology and a lot of really hard work in engineering and big computers. So in terms of winning at games, computers are good at least some of it. Still a long ways to go on the game of Go, if you've heard of that. But we continue to improve. By we, I mean the computers. I guess I like computers. I identify with them a little bit. I'm rooting for them a little bit. Okay, so another area in which there's been, so I asked about designing scientific experiments. I would say that humans still hold the edge overall, especially if you include grant writing and paper writing and paper publishing. There's been one case of a piece of software writing a paper that got published, but it was not at a good conference. It was at a really bad conference, as you might guess. It was complete nonsense, but convincing looking nonsense. So in terms of just looking at, once you reduce it to the question of scientific experiments to a restricted domain where you have some experiments you can run and some data to analyze, in this case, they've developed a robot arm that's actually able to design and run experiments all on its own and look at the data and analyze the hypotheses and figure out the next steps to do in order to rule out more hypotheses and make more progress with research. So it's limited in that there's only so much that this robot arm can do. There's only a certain range of questions it can think about, but it's actually able to make some real contributions to science in this area. I heard it described as performing at basically the level of a pretty good grad student in terms of being able to run experiments, look at a data, and figure out the next experiments to run. And I think that's exciting. You can see some quotes there about this robot that's already doing science. And one way of thinking about science is it's like a game where you're trying to figure out some puzzle and rule out possibilities. And so from that perspective, if computers can play games, then why can't they design scientific experiments as well? It's just another kind of game where you're trying to uncover something and solve something and win at something. Anything to add? OK. So there's been other work on trying to look at data and figure out the dynamics among a bunch of variables. So imagine that you're Isaac Newton and you're running some experiments on dropping things and timing things and measuring things, and you want to figure out the physical laws of the universe. Well, they've programmed a computer to do similar things. You give it some data, and it tries to analyze the data and look for patterns and figure out the dynamics of whatever you give it automatically and come up with an equation that describes that. So I think that's also exciting. So in terms of designing scientific experiments, humans aren't yet useless, but computers are making progress to where they're at least able to help us increasingly. So for creative design, do you think a human made this or a computer made this? Computer? So it's a matter of debate whether a human or computer made this, because so this piece of art was created by an algorithm. But a human wrote the software, and a human was presumably involved in choosing exactly what it generated. So when you get some of these combinations of algorithms and humans, it becomes a little bit of a fuzzy question exactly to what extent is it a human or a computer or some combination like I guess a cyborg. Maybe this is cyborg art because it's a combination of a human and a computer creating it. Or if you have a human with a calculator comes up with some knowledge, is that a human or a computer that came up with the knowledge? Well, the human used the calculator. But as the calculators get smarter and smarter, it's a more and more ambiguous question of exactly where the intelligence lies and exactly how that collaboration works out. How about this one? Human or computer? Computer, human? Sounds like the majority are saying computer. Oops, wrong way. So that's actually oil on canvas. So that's a human. But apparently his job is in jeopardy because we think he can be replaced by a computer. So, and from the number of hours that some people spend looking at screensavers, perhaps artists should be worried. So human or computer? Computer. So I'll tell you, a human took the photograph in the lower right-hand corner. And then an algorithm was applied to the rest of it to approximate it in some interesting way. So maybe this is another piece of cyborg art. And this one, human or computer? Human, yeah. So that's Andy Warhol. Again, taking a photograph and manipulating it. So a lot of the things humans can do with art, computers can also do. I've heard of a computer that generated, it was like Bach sonatas, Bach pieces of music that were very much in the style of Bach. Unfortunately, this piece of software no longer seems to exist. It was created back in like the late 80s. And I guess the creator just sort of got bored with it, because when you can create a bunch of pieces of music that sound similar over and over again, it starts to get less interesting. So we looked for more examples of computers creating interesting art, and there's some out there. But for many of them, they can do some cool stuff, and then they succeed in doing that cool stuff, and then people stop caring. So hopefully people come up with even cooler stuff in the future. Although right now, there's been a lot of progress on computers doing useful stuff, which is also exciting. So is this human or computer? Human? So that was actually an algorithm that came up with that. When I looked at it, I was like, I couldn't remember for a minute, which to me was a good sign that the line is starting to get blurred. Okay. Human or computer? So that would be Jackson Pollock. Human or computer? Human? Yeah, so this is human. Good job. Human or computer? Computer, cat, child. Close, close. Elephant. So the ideas of cat and child were actually closer than perhaps you realized. Yes, elephant. So next week we'll be discussing if elephants are intelligent or not, and if elephants can predict the probability of rolling boxcars and craps or not. Human or computer? So this is, a computer was involved in it. When it's a collaboration between a human and computer, I'm not quite sure what to call that, but a genetic algorithm was involved in creating this, at least partially. Human or computer? So this would be Escher. Classic. Yeah. Okay. So that was some fun sort of visual Turing tests for art. Any questions or comments before we switch to the Turing test component? Here, I'll just. Okay.
Is someone going to describe the test again?
Want to describe the test?
I'm not sure what we're doing. So
Okay.
Maybe we should ask your questions first.
Well,
right?
I mean, how's this set up?
Okay, so.
Any questions so far? No question. Yeah.
Okay. I feel that like initiative kind of has. I mean, I'm not sure if it's intelligence, but it's definitely kind of like a human thing. Because like going through the art, there were a lot of things where the algorithm was created by the human, and then the computer executed it. But if the computer like initiated a process of creating art, I feel like that would be a lot more intelligent in a human sort of way.
Mm-hmm.
It's just a thought I had.
So if the human is in charge and running things, and the computer is just an assistant, then it's mainly human-created art. Whereas maybe if the computer is doing more of the planning and designing and coming up with things from scratch, and just tells a human, go create this with paint now that I've designed it, then maybe the computer's in charge and the computer's creating art. I think that's a fair distinction.
Mm-hmm.
So, correct me if I'm wrong, but essentially, artificial intelligence is the ability of a computer to take an information,
understand how to process that information through like algorithms and logic functions, and then output data based on that decisions. And then with artificial intelligence, it also has the ability to modify how it handles that data based on output and also input, like with Cornell. Is that?
That's a reasonable definition. I'm not sure that there is one single definition of artificial intelligence. So the way I define artificial intelligence is computers doing things that if a human were to do them, it would require intelligence.
Okay.
So like figuring out how to get from point A to point B on the map. Well, Google Maps does it very well. Is that a simpler algorithm or a complex algorithm? That's at least some artificial intelligence, because it would take a human some intelligence to figure out how to do that.
I guess my question then is, wouldn't the artificial intelligence ability of a computer be somewhat limited based on how well a human individual can program that computer to have that level of intelligence? Because in order to handle data, in order to process data, you need to tell the computer how to handle that data and how to process it. And to a certain extent, the computer can adapt to process it more on its own. But wouldn't that necessarily or essentially be the limitation of artificial intelligence, is human intelligence?
Right. So
that's the learning piece that often comes up. That's an objection that's often given. But if I can program it, if I can tell it to learn, then you're off to the races. So, but we're not quite there yet.
Yeah, because even then, you would still be your ability of how well you can program it to learn. So it is still kind of.
How is your ability better as a human? What do you have that the computer can't have? Maybe I can ask that. So if I can tell the computer to learn and so forth, how is that different than how you learn and become intelligent?
Well, I don't think it would necessarily be the how you could tell the computer to learn. It would be your ability to tell the computer how to learn.
So humans don't have the ability yet to program this in.
Yeah.
I mean, that's a good argument, I think.
Well, I think he was just kind of saying that humans don't have the ability to program to make something smarter than humans as a whole. That we can't make computers more intelligent than humans are, because how would we be able to give them that ability to surpass ourselves?
Do you think that's just an inherent limitation of the universe?
Yeah,
or
that's what I think. It's just we can't.
So we'll never be able to kind of pass on what we can do, or
we can't surpass what we can do.
So
we can bring computers,
but
probably.
Clearly they surpass a lot of things we can do, but there's this last piece that we'll never get to. Is that sorry?
See, everything you said, it's not an uncommon opinion, but everything you said could also be, I could take what you said and apply it to arithmetic and say that computers will never surpass humans at multiplying numbers, because everything a computer knows about numbers was taught to it by a human. And yet computers, for the most part, can multiply bigger numbers a lot faster than I can. And they can also sort through billions of web pages a lot better than I can, and recommend them with much more accuracy than I can. So if a computer has enough data to process and enough time to think about it, then it may be able to capitalize on those advantages relative to what a human can accomplish in one lifetime. Maybe. Yes?
In response to that, isn't that more of a matter of computational speed? I mean, it still would have its limits at the computer. Like being able to sort through a billion web pages.
Being able to sort through a billion web pages in a fraction of time, which wouldn't be possible for a human at all, gives it a greater speed to do that. And it's able to assess the information greater, but still, I think that I think it's just like the diversity of information that a human takes in from a lifetime. It learns to process it all. It's almost like a nature versus nurture type argument.
Let me ask you another question. This is kind of a Kurzweil. Ray Kurzweil is a big guy on what if I could model the brain at let's say the neuron level? I could build a simulation at the neuron level of the brain. Do you think I would then have, and I somehow put this in my computer, would I have an intelligent computer at that point? Do you think?
I think it would depend on the information that was being sent into it, but possibly, yeah.
Well, I'll choose someone in the audience's brain, and we'll simulate that. Because we're not that far off, I believe, from that happening, being able to simulate a brain at the neuron level. I'd say next 20 or 30 years is what the kind of prediction is. So with that, if I had that simulation, do I have everything I need? Would that be the end of the story?
I think it would be like it would be able to understand just as much as a human could, and probably faster.
Right.
But it wouldn't be able to surpass the abilities that humans have to understand. Like it could take humans much longer to get to the same conclusion, even over generations. But it's something that's still only
not
our brain can
more
do.
intelligent.
We can't program something that's smarter than our own brain. It could be faster, but not. It won't have the capacity to go beyond our own.
But it depends on how can you define smarter. What do you mean smarter here, right? You finally compute that the human doing the same things just with different speed or different efficiencies, but we can still think they're same smart, right? But not smarter.
What would shock you if a computer did it? What would be, you'd say, man, I don't see how they possibly ever did that.
Well, I think a computer can do anything that humans can, but just like a dog can't understand astrophysics, I don't think a computer can go beyond what humans can.
Does everyone agree with that? I'm kind of not agreeing with it. I'm having a hard time putting it in words. Yeah.
I disagree. And I think Dijing can address this. The Bush administration got into a lot of problems with data mining the phone data, if you remember this. And I don't know if you guys know what data mining is, but my understanding of it is it's the idea that we teach the computer how to learn, and we have no preconceived notions about what it is that it's going to learn. And the computer can come back and go, oh my God, there's a terrorist attack about to happen, and we have no idea why it said that.
I have a question. We keep talking about intelligence in terms of what the computer is able to like process or produce, which can all, it's just like things that could be programmed in. Are you guys aware of any instances of computers like expressing personality or individual identities? Has there been any cases of a computer like refusing to do what it's programmed or making like conscious choices like that? Because I think that would really be, to me, the sign of intelligence.
That's a really good question. In the early days of AI, it was highly controversial. Someone back from Beijing School, Roger Schank at Yale, was saying he could program love and all kinds of emotions in just kind of with variables. So love, ranges from 0 to 10, and I'll make it 6, and so forth. That caused a big stink and is now, I think, kind of discredited. So I don't know if that work is still going on. Any notion of building personalities or human emotions.
Yeah, there was a project. Around 2004, kind of before I left Yale, and we have a robotics researcher there, and they built a kind of baby robot or children robot. Just looks very young, and then they figure out it's interesting that the children have autism like to talk with the robot, but autism means they don't want to talk with anyone else, right? But then finally they figure out the children in autism have kind of higher possibility to talk with kind of baby robot. So that maybe answer your questions. That means maybe robot or computer can do something, not only just simulation, but something little different from human.
Just to follow up on that, sorry to David, but there's a book by Feigenbaum that says, he calls that obscene. So the notion of putting computers in places where there should be some shared emotion or shared experience, like a judge, a nurse, and so forth, he calls obscene because the computers, this was a while back, probably 20 years ago, but we just shouldn't be doing that because the computers don't have the shared experience. They should not be dealing with children. But we tend to want to believe they're smart and so forth, and they have personality. So, you know, let's make them judges, nurses, whatever. So I'd say it's controversial in the field. That was actually a question.
I think for the most part, people will add emotion or individuality to a computer program if it helps that computer program accomplish some task. And most of the time, for most tasks, it wouldn't help, and that's why there's occasionally research on it, but it's hard to measure the value or the significance of it because, okay, so suppose that I write a computer program that generates a random number to pick what color the menu items are today. So with randomness, it picked a number and it expressed some individuality. Is that it choosing? Is it just randomness? What counts as emotion and personality and what doesn't? And you can make it more complicated, but you still have this question of what role is that individuality serving and how is its motions useful here? In terms of having diversity among a population of intelligent things, there's been work in sort of artificial evolution where you create a bunch of computer programs and have them sort of compete with each other and evolve over time to accomplish some task. And for example, those genetic algorithms that you saw that were referenced as helping create that art, those are examples of this artificial evolution where you have a whole bunch of different random programs or random ideas or random parameters or configurations, random settings of a program maybe, and you try them all out, and whichever ones are best, you take those and you copy them and you mutate them a bit, and you repeat over and over again, and if you've set up things well, then hopefully it will converge to something that's much better. And if you set it up poorly, then it will be random and bad. So it requires some tuning and tweaking, but that is sort of an example of individuality and personality in a population where it helps because that diversity lets you explore some different methods and then combine them in sort of an evolution-like manner.
So I have another comment. You guys seem to think that emotion is a form of intelligence, and I would actually say that taking emotions away is a form of intelligence because there are people that I just hate, and I will not help them at all, even if it's in my best interest to do so. So it seems like taking that away
Depends on what role you're putting in the computer. I mean, as I said, if you want a doctor or a nurse, then you might want some shared experience. In other cases, maybe not. So, just let me, go ahead, yeah.
Well, also, I think it depends on how you define intelligence, because then people say that there are different kinds of intelligence, like emotional intelligence, for
Right.
instance. You know, so that's just kind of a different parameter. So I think when we're talking about artificial intelligence, it depends on how we mean. You know, because are we talking about the ability to process algorithms, or are we talking about the ability to be compassionate and to listen well? Like, I mean, I think that those are two different facets that could both be defined as intelligence,
Right.
depending on how you view intelligence.
Right. Well, what role you want your machines to be playing. Just one other thing. I think I could almost argue this Turing test and what we're talking about is a little bit of a red herring because I think really I'm channeling Ray Kurzweil again, sorry. And that is the cyborg angle. So the notion of you in the future having a hard drive with a direct brain connection is not that far off. And it's happening now. I mean, there's I don't know how many conferences on direct computer-brain interfaces. So this is happening, and I think in your generation, this is going to be something that does happen. So I think this whole cyborg thing is much more interesting. Well, that's not more interesting, but it's something you guys are going to deal with fairly soon, I'm guessing, in the audience. So it's almost a policy issue. You know, how much are you going to let someone put something in your brain or attach something to your brain? And when does that, how does that all shake out in terms of intelligence?
This is a question that's kind of unrelated. Sort of talking about cyborgs and stuff. It makes me think of Simon Hawking, the Neuromancer, and in that book they have the turning points where they are authoritarian force that assesses artificial intelligence. If they find something that passes the Turing test, they say, okay, well, it has to be destroyed. And the reason they're doing that is because they're trying to keep, they realize that artificial intelligence, if it does gain the ability to advance, and we're being kind of sci-fi here, could be threatening or unethical or used unethically. So, I mean, where do you
I mean, I think it's huge. I mean, you know, so, you know, in the future, maybe the rich among you can afford these things and others can't. I mean, I think it's I think that's the policy issue you guys are going to be dealing with.
My question is, though, where do you think we'll go with that? I mean, do you think there'll be legislation controlling artificial intelligence?
I don't know. But it's all benign. I mean, the last thing I saw was someone, you know, for someone who was blind, going into the cortex to give them vision. And, you know, who can say that's bad? So it's usually to make up for some impairment, but eventually I see these things as products you guys will be able to buy. So, I don't know. That's my thought.
My question kind of circles back to the comment that intelligence is here about how to create, and to tie it more back into the artificial forms of evolution. Could a computer's intelligence essentially surpass that just created by another computer? I know it kind of plays into the sci-fi element of computers making computers and but evolutionary-wise, it would make sense that that could happen. I would just like to ask your opinion.
Why not? I'm bad at predicting the future, so I don't want to give any, you know, time spans. But computers seem to be evolving at a pretty fast rate. Right now, it's with our help, but what will that look like long term? I'm not sure, but I think it's exciting to think about. So, have you heard about people talk about the singularity?
That's, again, a Ray Kurzweil.
Also, like Werner Vinge and a few other people. So this idea, mainly a science fiction idea, that computers will reach this point where when you have artificial intelligence and nanotechnology and the ability to back up human brains, everything will be so different that you can't even imagine it. And then they actually try to write books about a future so different you can't even imagine it, so that you can imagine what you can't imagine. And it's kind of trippy.
Daniel's a doubter. I'm a believer. You have two different. The singularity, by the way, is I think about 25 years off, according to most of them. But it's a simulation of the brain. We'll have nano. We'll have all kinds of technology coming together at one point. That's the general idea.
I'm very optimistic, but I don't like to make strong predictions. So there's a trend. If you look at AI people and their predictions about, you know, when we will have the ability to download the brain, they usually predict that we'll have the ability to download the brain right around when they turn about 70, and they're starting to get old. They somehow predict that we'll get human immortality shortly before they need it. It's an interesting coincidence, but that's a tendency. Kurzweil certainly falls into that camp where predicting human immortality through computation, you know, right before he would need it.
Yeah, I think that remind me the movie. I mean, some student mentioned the Matrix. That's my most favorite. The movie seems very sophisticated, right? Because seems AI try to kind of remove all the humans, right? The human always try to survive. But finally, people get some kind of negotiations, right? And with AI, actually the back end of philosophy, I think, is exactly what the first pioneers talking about, the completeness and consistency. Because think about this, if there will be a AI world, there's no human, right? That is a very clean, consistent system, but it cannot be complete. So if we want the world to be a complete world, we need both human and machine, because that's the philosophy behind that. So that's the reason I'm kind of okay for whatever evolution theories, but I guess there's some balance will be happen, and a very simple balance. So don't worry about that. Mm-hmm.
And so, like, you know, with the Matrix, we assume that they'll want to control everything, like we assume humans do. You know, they'll be wanting to dominate the world and to, you know, go to war and all of those sorts of things. So, I mean, I just realized with that comment that you had that that's an assumption that I had made, and that maybe if we did create artificial intelligence, they'd be nothing like us, and they would have no interest in controlling the world or anything like that. So that was just a very interesting thought.
Yeah.
As we discussed earlier, a lot of the applications of artificial intelligence aren't necessarily trying to exactly simulate humans. It's trying to do things better than humans. You wouldn't want to exactly simulate what a human was like recommending web pages, because that would be slow and inaccurate. And Google's building self-driving cars. There are now laws in Nevada that allow self-driving cars to some extent. That's a recent development.
Why Nevada? I wasn't
Because they have large open spaces and not too many people, and it's fairly liberal there, right? So California, you have to imagine California isn't going to approve that for a while, because it's scary. But robot cars have the potential to be vastly safer than human drivers. And I think you'll see many of the applications of artificial intelligence will be doing things that humans do, only better or cheaper. And do we need a full personality that can have a conversation with you and talk about its hopes and dreams for the future and conquering humanity? Well, if we decide that's useful and really want to build it, and then maybe, but a lot, in at least in the near future, a lot of these developments will be things that are useful, like self-driving cars.
Yeah, have a question? Okay. Think should move on. Yeah.
Okay. Let's see if this works. Okay. So supposedly, this Google document that is shared will allow us to type to both, type to humans hiding in another room, and they will put in both the answers of a computer, a chatbot, and the answers of an actual human to whatever questions we ask. And hopefully this will let us figure out. Oh, yes, good idea. So now is your chance to represent your species for all eternity. I think we have a volunteer.
Yeah.
Jim, what chatbot are they? Is this, you going to say something about the chatbot?
And one question, will it be two separate conversations or one merged conversation?
So what we have in mind was you guys agree on some questions, and she'll answer it, and Tuckerbot will answer it.
Okay. Okay. It's been in a few times. It does okay. I don't know if it won last time or not. So now is the time to start thinking of questions. Um,
I don't think they have to be yes or no.
yeah, so these should be questions that are interesting enough that they would help you identify a human relative to a computer. So I'm guessing that you all will win in terms of figuring out which is the computer and which is the human, but how quickly you win will depend on the quality of your questions.
Yeah.
And the quality of the human, right? So.
Yeah, because if you ask very hard questions, then even human cannot answer, then you still cannot figure out which is human, which is computer.
So you want to think about what questions would generate a different response from a human than a computer. Is the other room cold? Okay. Oh, yeah.
Yeah, but I don't think this chatbot's going to lie. I think that's why it's a little bit different.
So Cleverbot is trained based on text that people on the internet type to it. And you know what people on the internet are like. They say all kinds of crazy things. So if Cleverbot says anything that is too obvious, like, yes, I'm Cleverbot, or too inappropriate, I imagine it will be censored. But for the most part, you'll get Cleverbot's answers. Aha. Answer 1. Exciting. Okay. Okay.
So, it's not going to be easy if you guys thought it.
So let's have a first vote. How many people think number 1 is the human? How many people think number 2 is the human?
But it's not bad.
Okay.
What's the room?
So next question.
It's not fair because we see the human.
Unwilling to say. I vote that's the human.
Okay. Other questions?
Why it takes so much time for this question? Yeah. So we need to calculate the average age of the people talking about that.
It's possible that human machine number 2 is actually in The Sound of Music. Was it 15 going? Was it 16 going on 17? Ah, I fail music trivia. I'm not a human, or I'm not. I don't know.
when you eat supper. There's a long way to go to pass to intelligence.
So it appears that if you want a job impersonating humans on the internet, for now your job is safe. Any other questions you have for the intelligent or non-intelligent entities in the other room?
I think he's watching. That's the first time we see. He's from New York, right? So actually it's hot, right? This one.
So it looks like what's your favorite color is a less useful question for distinguishing computers from humans, at least by my estimation. Maybe it's obvious to you from those two answers. Any other questions? And the other one, I'll just. Okay.
But I think depends on the human answers, right? I mean, human responders. He or she may have intention to try to distinguish from the computer. Yeah. Yeah. Computer. I think the goal of Turing test is the computer try to deceive, right? But the problem is the human needs to be maybe like fair, right? Otherwise, yeah, human easy to make some answers, only human kind of thing. Yeah. Yeah.
Oh my God. What do you think is funny? I hope it's not me. That was kind of strange. I don't think either of them.
I don't know if the first and second respondents are consistent or if they're mixed up each time. I actually don't know the answer to that.
Yeah. How can we know the answer?
Any final questions? I think this is sort of winding down a bit. We have a sense for what it's like to talk to humans and talk to bots. Hopefully most of you know what it's like to talk to humans. Years of experience and all. How about the final question? Are you human? Sure.
Are you human?
Okay. Final question.
that test is the human subject cannot know what is the purpose of the test. Yeah.
Hello?
Yes. Yeah. Can I ask you a question about the Turing test?
Sure.
Is the job of the computer to deceive the tester so it can lie and do whatever it wants to?
Sure.
Yeah, that's what I thought.
The job of the computer would be to emulate the male subject,
Right.
which is, who is meant to deceive.
Right.
So
And then the human is meant to just be fair, tell the truth, or.
No, we told her to pretend like you're a computer.
Oh, but that's not part of the Turing test, is it? The human tries to pretend like they're a computer?
Yeah, I think they're both.
Oh, I didn't. Really?
well, see, well, the Turing test again. There's the imitation game and the Turing test are slightly different things, but the imitation game boils down to one subject trying to deceive the interrogator into thinking that the respondent is not is something other than the subject. I'm sorry that didn't parse very well, but the Turing test is not quite the imitation game as Turing presented it, but it's a distillation of it in some sense.
If we move the computer
human?
And number two is computer.
And number two.
Just want to note on this, there is a prize. I think the chatbot was in it. It's called the Loebner Prize. It's $1 million. I think it's $1 million for the first new chatbot that was passed in terms of over this year. No one is, no chatbot has passed it yet, although,
They give prizes for the most human-like computer. So even if you don't fool the judges, they rank how human-like the different computers are. And they also rank how human-like the humans are. So if you're one of the human people, you can try to be the most human, which is an interesting thing to think about what that means. There's actually a book recently written on it called The Most Human that talks about a lot about this idea of what it means to be human and what it means to be a computer and what intelligence is. And I haven't finished reading it, but from what I've read so far, it's a fun read. Is that it?
All right, so it looks like we're wrapping it up. So thank you all for coming, and let's give our panelists a round of applause.